Hello, and welcome to Advanced Mathematics 1, Unit 1, Part 4, Properties of Exponents. By the end of today's lesson, you'll be able to do the following things. You'll be able to use zero and negative exponents, and you'll also be able to use the properties of exponents. Our main concepts for today are as follows. For any non-zero number a, so in other words, as long as a isn't 0, a to the 0 power is 1. So you can raise any number to the 0 power, it's always 1. And if you take a to a negative power, it's the same as taking 1 over a to the positive value of that same power. So in other words, a to the negative 2 is 1 over negative 2. A to the negative 2 is 1 over a squared. Sorry, misspoke a little bit there. Apologize. All right. The other properties are if you take the product of two exponents, a to the m times a to the n, you get a to the sum of the individual exponents, m plus n. If you have a quotient of two exponents, a to the m divided by a to the n, you can get this number by taking a to the m minus n power. When you raise a power to a power, you multiply the exponents. A to the m raised to the n power is a to the m times n power. And last but not least, if you raise a product to an exponent, it's the same as raising each individual piece of that product by that exponent. So ab to the nth power is the same as a to the nth power times b to the nth power. All right, same thing for quotient. A over b to the nth power is a to the nth power divided by b to the nth power. Those are the properties of exponents. All right, so let's just jump in. Now there's a lot of different ways you can go about doing these problems. If you don't like the way I do it, don't worry about that. I don't like negative exponents, so I tend to try and get rid of them as early as possible. But when I'm raising anything to a power, I generally go ahead and multiply the exponents first. So I have 3 to the 0 raised to the negative fifth. So 0 times negative 5 is still 0. So I end up with 3 to the 0. Then I'm going to do for the numerator, I have x to the negative 5 to the negative 5. So negative 5 times negative 5 is 25. And then y squared to the negative 5. So 2 times negative 5 is negative 10. And then I'll do the denominator. Z squared to the negative fifth. 2 times negative 5 is also negative 10. Oops, negative 10. All right, now I want to get rid of my negative exponents. 3 to the 0 power is 1, so I can ignore that. I have two negative exponents. That means they are going to trade sides of the fraction. So I'm going to copy what I did not circle, which is x to the 25. The thing that I circled in the numerator goes in the denominator, but now with a positive exponent. And the thing that I circled in the denominator goes in the numerator with a positive exponent. There's nothing else that can simplify here because there's 3 different letters, so I am done with this problem. The idea is to get rid of all the negative exponents when we're done. All right, in example 2, we just have a bunch of things raised to different powers. Again, z to the 0 power is 1, so I can basically ignore that. Now I'm going to take care of my negative exponents first. So I'm going to find those. So I have 2 squared in the numerator, which is 4. And then the things from the denominator that were circled, which is 8 to the first power and x to the 7th power. And then in the denominator, there's nothing left down there other than that thing that I got rid of. So I bring the thing that was circled in the numerator down to the bottom. So now I want to simplify this. 4 times 8 to the first is 4 times 8, which is 32. And then I have the x to the 7th and the y to the 6th. So again, I can't simplify that any further, so I'm done there. That's all for that. All right, in example 3, we have two things raised to powers that are multiplied together. So I'm going to work on each parenthesis separately. So I have 3 raised to the second power. M to the negative 5 squared would be negative 5 times 2 is negative 10. N squared squared is 2 times 2 is 4 on the n. And then I have 4 squared in the bottom. You can go ahead and do those right away if you want. I'm just writing them out. M to the negative 2 to the 2 is negative 2 times 2 is 4. Negative 4, sorry. And then 0 times 2 is just 0. And then I'm going to multiply that by this one. So I have m squared, because there's no power on m already, so I can just raise it to the second power. N to the 4th squared, it'd be 2 times 4 is 8. Oops, 8. And then 29 squared in the bottom. And n squared in the bottom. Now there's a couple ways you can go about doing this. Like I said, you could simplify along the way if you want. I'm going to take care of my negative exponents and kind of simplify my numbers as I go. So I'm going to take care of everything that's not circled up top. So I have 3 squared is 9. I have an n to the 4th and an n to the 8th up top. So I would add those exponents. 4 plus 8 is 12. And then I have that m squared up top. And then I'm going to bring the thing from the bottom up top as well. So I also have an m to the 4th. In the bottom, I have 4 squared, which is 16. I have n to the 0 power, which is nothing. 29 squared, I don't know off the top of my head, so I'm going to figure that out. That's 841. And then I have the n squared. And then I have this m to the 10th that was up top. All right, now I'm going to simplify both the numerator and the denominator. I'm going to write it over here. 9n to the 12th, m to the 4 plus 2 is 6, over 841 times 16 is 13,456. And then I have n squared, m to the 10th. Now, with quotients, you subtract the exponents, but what I like to do so I don't end up with negative exponents is I subtract them and leave the answer where there was more. So in the n's case, there's more in the numerator, so the subtraction is going to end up on the numerator. In the m's case, there's more in the denominator, so the subtraction is going to end up in the denominator. I'm going to see if 9 over 13,456 can simplify. And it cannot. So then the numbers are not going to change. So I still have a 9 up top. So the n's are going to end up in the numerator. There's 12 minus 2 left, leaves me with 10. And then I have that 13,456. And then 10 minus 6 is 4 m's left over in the denominator. And that's my final answer. All right, moving on to our last example. Our last example is a distributive property. So I'm going to distribute this fraction through both parts. So you multiply numerator times numerator, denominator times denominator, and then the same for the other fraction. So in the first fraction, I have m to the negative 2 times b squared. There's nothing that I could have simplified there because they're individual letters. And then I have in the denominator b times m cubed. That's first fraction times first fraction. Now we'll go on to our second fraction, which is after a minus. So I might as well copy that 4 up top because that's not multiplied. There's no other numbers. The a is up there. M to the negative 2 times m squared would be m to the negative 2 plus 2, which is m to the 0. In the bottom, I have b times b to the 4th makes b to the 5th. Now I just want to simplify those as much as possible. So again, I have a negative exponent here I'm going to take care of. So right now I have a b squared up top. I have a b, an m cubed, and an m squared in the bottom. And then over here, the m to the 0 it becomes 1, so that basically goes away because 1 times anything is the thing. So this one just becomes 4a over b to the 5th. So now I just have to simplify this. B squared divided by b is just b in the numerator. And in the denominator, now the b's are taken care of. I have m to the 3rd times m to the squared, which is m to the 5th because you add the exponents. And then I just copy the rest. So the key is to take your time with these problems and be very thorough. If you want to do the additions before you move the negative, that's fine. It really doesn't matter what order you do things. It's the beauty of these problems is that you kind of have a choice as to how it works for you. So work on the problems, see what works for you, see what you like, and do it that way because that's the best way for you to do it. It may not be my way, okay? So don't feel bad if you don't like my way. That's okay. It's all good. All right, see you next time.